trigonometry, right? We covered, of course, we covered basic one. We have lots of material to cover, so we have to move forward. But if you have any questions, I will take your questions. Okay, so we're gonna put after your questions, we're gonna basically put trigonometry behind us for now, but it doesn't mean you're not gonna have any questions. As you dive into more of those exercises, of course, you're gonna feel like, oh, I have more questions, but just bring those questions you know, to the class or to my office hours. I'll be happy to answer. But the important part for you is really to practice, okay? If you look at the notes, it's covered, it's full of exercises, right? It's full of exercise. And our student needs exercises, okay? So if you would just give yourself the gift of time to practice, which I cannot substitute you for, okay? So you have to do it yourself. You have to do it yourself. So anyway, without further ado, and I'm sure you fully understand that, do you have any questions here? Everything we have covered from basic one, okay? Basic one is a very comprehensive summaries of the basic functions. And we covered all of the functions. And that's majority of this notes, actually. That's the majority of these notes. If you look through all these exercises, they're all related to basic one. They're all related to basic one. It's just different interpretations. From trigonometry, I hope I have given you a glimpse of how they're interpreted, right? The meanings. And of course, we're going to touch other topics as well. No questions so far? Let me see what's on chat. Okay, no question on chat. Okay, this is week number 6. Time goes by very, very quickly. Okay, time goes by very, very quickly. All right, so today we're gonna have a change of topics, okay? And this is, this topics is related to one of the functions in basic one as well. Okay, so today we're gonna cover about this function once again. F of x equals to absolute value of x. We have covered this function, didn't we? We did this function. Remember what we did at the time? Domain and range. And then we're gonna get to basic 4. Basics 4. Okay, so from basic 1, we take one function out of it where we covered before. How did we cover that before? You guys remember? This function is a very, very important function. You will encounter this function almost a couple of weeks into your calculus class. Okay, no calculus class can get around this function without having to deal with it. Usually you will get 20 or more points or lose 20 or more points because of this function. I'm not exaggerating. Okay, I'm not exaggerating. So you either get a 20-some points because of this function, or you lose 20 points because of this function. Okay, remember we covered this first, right? We covered this at the very beginning when we do basic 1. About this function, there are much related topics. Okay, so that's what we're gonna cover. This is the second time we cover absolute value of x, this function. Okay, to recap, to recap. Okay. We talk about the domain and range of this function. We talk about the domain and range of this function. And that was number 6, you know, in basic 1, number 6, right? It was in basic 1, number 6. Okay, and then we're looking forward to basic 4 and a series of questions related to basic 4 all the way up to basics 7A. Okay, up to basic 7A. And of course, there are some other stuff, but mainly we cover the main thing here. Okay, so let's recap. Do you guys still remember the domain and range?
Domain is all real numbers.
Graph, right? All real numbers, very good.
And the range is greater than 0.
Greater than 0?
Yeah, or x, absolute value of x is greater than 0. Or equal to, sorry.
That's right. If you give me this answer, it's wrong. Okay, greater than or equal to 0. Okay, and there's a graph. What is the graph? We did the graph. Okay, what is the graph? What does the graph tell us? It's all about meaning, right? It's what's the meaning? What's the meaning? Right? It's a function, right? It's a function.
It's not 1-to-1.
I'm sorry?
It's not 1-to-1.
It is not 1-to-1. Okay, very good. What else? Do you have the graph? Right? And we have also that we also have that narrative, don't we? Have that narrative. The absolute value of a non-negative number is the same as the number. We did that, didn't we? We did that. Okay, so can you refill that gap? I'm totally ready to go over this with you again, provided that you are thinking about it. Right? You guys write down the narrative. The absolute value of a non-negative number, is the same as the number. Yeah. You guys do remember that? Does it still make sense? The absolute value. The absolute value of a negative number is its opposite. Okay, even when you are in calculus 2, you're still using this from time to time. Okay, it's a little thing. Okay. All right. So you know the graph, don't we? Do we know the graph? It's a V form, and the graph tells us exactly what we're saying here, right? So I'm kind of, you guys get the graph, yeah? Now, look at basic 4. What does basic 4 say? Basic 4 says, solve for X. Okay, these questions you have seen them before, but I just want you guys to see it in a new light with interpretation. Okay, solve for X. So what does this mean? Right, solving for X. Take the first one, for example. Absolute value of X is equal to 3. What does that mean? If we talk about the only 2 kinds of statement in mathematics, right? And indeed, all of these is this is a description of a rule. Okay, this is a description. This is a function is a description of a rule. So we know this rule. Okay, and according to this rule, and we have this observation. So it's a statement. Well, in here, you know, this statement has the conditions. Okay, if that, you know, if there's a conditional statement. These are conditional statement. Now, when we come to solve for X, it's an if statement. What does it say? It's that if, okay, well, you can attach this if this function's output is 3. So this really means what? In this scenario, in this context, right? In this context, if the output is 3, okay? If the output is 3, what are all the possible inputs? That's the meaning. That's the meaning. And where do we find those input? From the domain. From the domain. Okay. So at this point, all these information we get here, you know, all the interpretations, these if statement, if the output is 3, so that's what's been telling us. If the output is 3, okay, there are 2 different interpretations here. There are the 2 branches of what, you know, we can do. And I'm sure everybody know the answer, don't you? What is the answer? If the output is 3, what are all the possible input would that be?
+3 or -3?
That's right. So see, when you know the meaning, the answer is obvious, right? It's 3 or -3. And sometimes we write it in shorthand notation, right? Shorthand, the shorthand notation usually is that X equals to plus or -3, plus or -3. Even though we put it plus sign, minus sign together, it really meant the key word is what? The key word is or. The key word is or. Did I do the truth table with you guys? No, I don't think we did it. Okay, we haven't done that. Truth table. Okay, we'll get to the truth table today sometimes. Okay, the keyword is or. The keyword is or. Okay. So with that said and done, for this question, there's another interpretation. One of the interpretation is the number line interpretation. Okay, and the other interpretation is the function interpretation. Okay, and this is what it is. This is the function interpretation. So we know the graph. We know the graph. And this if statement, right? This if statement basically says geometrically, okay, if this is true, right? And the meaning is if this if statement. If statement, okay? So if the output is 3, meaning we have a, let me make it red, horizontal line of 3 cutting the curve, okay? And there are 2 points of intersections. There are 2 points of intersections we have here, right? And we're looking for the input. We're looking for the input, okay? So now let's mark these 2 points. Let's mark these 2 points. Okay, red dot, and there's another dot. These are the 2 dots. Okay, so the function interpretation basically is saying, well, if the output is 3, we have a horizontal line because this is the output 3, right? At this level, output is 3. And these 2 points, right? Both points, this is 3, 3, and this other one is -3, 3. And what is the output? The output is here. This is the output. Both have the same output, right? Do you see that? They both have the same output. And what are the input that will make the output 3? That's the interpretation. Do you guys follow me? That's the interpretation. Does everybody understand? It's pretty simple, right? It's pretty straightforward, but we must understand this interpretation, okay? So if we go by the function interpretation, that's what it is. So the answer, of course, right? These are the 2 inputs that will give the output 3, okay? And so that's how we answer the question here. That's about the inputs. All right, is that clear? And the other interpretation is purely from the perspective of definition of absolute value, okay? So I'm gonna show you here. Okay? Oh, sorry. I'm gonna show you here. So what it is, what I'm doing here, okay. All right, is the input, right? There are 2 dots here. And on the number line, if we only look at the number line, right? You probably have learned this way. If absolute value is 3, so the other interpretation basically we don't care about this. Okay, this picture is just basically I'm not gonna look at this picture. I just want to I'm going to do this. Okay, I'm going to remove the curve, delete, and then I'm going to add 2 points. Okay, -3, 0. Okay, it's a dot, and there's another dot. Oh, sorry. I think I made a mistake somewhere. Wait, add, sorry, -3, 0, dot. Okay, so these 2 dots, and now we're gonna shrink it. So it's just on the number line. Okay, these 2 points whose distance to origin, which is 0 here, and that distance is exactly 3. So this is by definition. So by the definition of absolute value. So these are the two interpretations. This might be the interpretation you have learned before. Okay, so you're not going to see it as a function. You're just asking the question, what numbers whose distance to origin is exactly 3? Does that make sense? Okay, so with these are the basic 2 schools, and the first one, of course, is less covered, but now you know. Okay, I want you guys to remember these 2 interpretations. I'm going to summarize this in a table. Okay, I'm going to summarize it in this table. In this table, okay, I'm going to put these here. The first one, the second one. Okay, it's all about the same thing. Okay, just this one, the function interpretation. And this guy and the other one is just from the perspective of absolute value. Okay, nothing fancy, nothing fancy. Very important to understand at this point. Okay, and of course, what will be the solution? The solution. Okay, so I'm going to add a row here. Okay, and of course the solution we have we just listed there. Okay, that one. Same thing, same answer, no difference, no difference. Okay, does everybody get the interpretation and the narrative? Yes, okay, that's pretty straightforward, right? That's very straightforward. I want you to compare this with what we did with trigonometry. Remember when we did a trig 10a? 11, remember we did it with trig 10a. What was the interpretation? If sine x equals to half, or sine x equals to 1/3, something like that, do you see similarities in the wording? Compare. Compare with sine x equals to 1/3. What is that interpretation? What is that interpretation? Do you still remember? What does it say? If the output of this function is 1/3, if the output of the function is 3, do you guys see that similarity? What I emphasize is you look at the structure of the sentences, right? That if statement, the only difference is the rule is different. Do you follow me? The only difference is the rule is different. Sine rule is much more complicated, right? Sine rule is very complicated. You have ARD, you have all these things involved in a definition. And absolute value is a different rule. It's simpler. But it's all about input output, isn't it? It's all about input output, isn't it? Do you follow me? That's the point I want to make here. All of these functions, they're just different rules. Sometimes you give an input, you want to find output. Sometimes you give an output, you're looking for input. That is all. That's all we're dealing with. Do you follow me? When you're in calculus class, and what's being done is that you call all of these we deal with is called a function. all these different rules, and there will be more complicated rules built on more complicated rules. And they're all called a function. And then you start to do the derivatives and integrations and the left and right, all these different things. Okay, so now with that interpretation fully explained, okay, fully explained, understand its meaning, do you think you can handle every question in basic 4? Okay. To me, it's not all about the answers, it's about the interpretation and the narratives. So you look at basic 4, because we're going to move forward very quickly, okay? This topics is a difficult topics, but it seems easy. And a lot of students lose a lot of points in calculus 1. 20 points. My statistic tells me student who can lose on average 20 points on these topics in calculus 1. Okay. So basic 4. What are the answers? All right. I want you guys to pick 3 questions. Pick 3 questions arbitrarily from basic 4. Pick 3 questions. Pick 3 hard questions for you. Pick 3 questions, what you get. Do you know the answers? And you think from the perspective I just give you. Okay, you think from the perspective of I just give you. If you say, oh, I know this type, I learned that before, it's just always equals to plus minus something. And it lost the whole purpose of doing this. I want you to reflect on the meaning. I want you to reflect on the meaning. Yes, no?
I would say the 5. That
Number
stands out to
5?
me.
Okay, number 5, that's a good question. Number 5. If number 5 is absolute value is equals to -3. If, right? It's an if statement. It's an if statement. It's an if statement. Okay. Except here, we want the output to be -3. Or the other interpretation, whichever way you want. The number line, the function interpretation. So what do you think will be the answer?
Three. Right.
Choice A, the answer is 3. Do we have a B? Multiple choice.
-3.
X is a -3. C.
No solution.
Do we have a D? Do we have a D?
I couldn't think of a fourth option.
Sorry,
I couldn't think of a fourth option.
you couldn't think of the fourth option. Anybody else? No? If you have chose, if your choice is A, or your choice is B, that reflected you have no understanding of this function. You thought you understood, but you didn't. You didn't understand this rule. And you didn't understand the domain and range either. Okay? Remember that one sentence domain range we talk about? Right? What did we say there? We say the absolute value of any number okay? The absolute value of any real number is always greater than or equal to 0. When you bring that statement over here, when you bring that range over here, what does it tell you about this if statement?
It's not true.
It's never possible, right? It's never going to happen, isn't it? That's called analysis. That's called analyzing. If any number taken absolute value is going to be greater than or equal to 0, when will it be possible that the absolute value of some number is equal to -3? That's never going to happen, not in a million years. So these two answers reflected that you did not understand the domain and range at all. You did not understand the picture at all. You didn't understand what I just explained. Okay, my comments has nothing personal and or critical of anybody. It's just an objective diagnosis. Okay, so now if you look at it from this perspective, I just explained to you. We just explained, right? From this perspective, right? If we look at from this perspective, so the output become -3, right? -3. And what does that mean? This picture, okay? And the horizontal line will be where? Will be -3, right? Yes? Do you guys follow me?
Yeah.
When you want an output of -3, there's no touch with the curve. What does that tell you? There's no input to have that kind of output. Do you follow me? Are you guys with me? I spent that time to explain to you the interpretation, to give you the tool to think from it. Do you get it now? Okay, so now do you understand this sentence? I hope you understand this sentence a little bit better. Yes? And of course, for this case, right? Okay, I just put it. Hold on. Sorry about that. I'm going to this. This is going to be And I just the mundane details of using the software. There's no solution. There's no solution. Okay, there's no solution whatsoever. So now that you understand why I give you these two interpretations. Okay, I need to remove these 2 points. Delete. The software sometimes it doesn't obey me. Okay, so there's no solution. Yeah. I totally screwed up. I'm sorry. This should do. What's going on here? Okay, never mind. No solution. It's no solution. Do you guys follow me? Because you think about it. What does this sentence imply? If this is, do we agree that this is always true? The absolute value of any number is always greater than equal to 0. What does that mean? What does it imply? Its opposite will never be true, right? Right? Its opposite will never be true. Will never be true. So how many cases are there in the category of its opposite? Think about it. One true statement implies what? Implies that the opposite of this true statement will not be true. So can you give me a couple examples of its opposite? That in the category of its opposite. You follow me? So math teaches us how to read a statement and figure out its implication and identify its implication in special cases, in all the cases. And that's called critical thinking. You follow me? That is called critical thinking. All right? So is this statement, is this if statement, right? This if statement, if the output is -3, all the possible output will be greater than or equal to 0. So if for output equals -3, it's never going to happen. Does that make sense? Therefore, you have no input for it, no solution. Does everybody follow me? Okay, so number 6, what is number 6? What's the solution for number 6? You can do number 2, number 3, number 8 by autopilot, right? But for truly understanding, you have to be able to explain for number 5 and number 6. So these are the tools you have. These are the tools you have. Okay. Now, so what is the question? What is the answer for number 6? Yeah.
It is true because
it is true. One is true. It is
what?
asking if what is when it is true.
When x equals 0.
We should say it can be true. We should not say, because it's an if statement. The if statement basically asks us when, if this is a condition, when will it be true? Then the only answer we can give is it can be true, and you tell when is it going to be true, right? You cannot say it is true. Do you guys follow me? Do you think I tell the difference? You're given an if statement. Okay, I want you to think from that if statement. That's what I'm trying to get you guys to do, really. I want you to think in words. Think in words that make sense to us. Okay, so number 6, what does it say? Getting the answers is not the only goal, right? It basically says if the output is 0, if the output is 0, you guys follow me? I'm really just trying to get you guys to use that sentence. There are 2 kinds of sentences in mathematics. You just have to learn to use these 2 sentences and embed them in your thinking. Do you follow me? So if the output is 0, is there then an input for it? Is then an input for it? And now you look at this. You look at this statement, right? You look at this statement. The absolute value of x greater than or equal to 0 for any real number. This is a true statement, and equal to 0 is one of the cases. You follow me? And therefore, the solution would just be x equals 0. Yes? So I'm going to give you a summary as to how you're going to show your work. Okay, I know I have given a lot of explanations, and some of you may say, oh my God, how am I going to explain this? Okay, all my explanation is to make you understand the actual answer to these questions actually is very simple. It's very straightforward. So I'm going to give you that I'm going to give you that answer. The answer is 0. Okay, so when you are asked to solve these equations, okay, how to show work, you need to understand what I just explained to you. Okay, how do I assess if you do? Well, that's a $1 million question. How do I assess your thinking? I don't know. I don't know how to assess your thinking. I just have to make up some, questions, for your quizzes to assess, do you really understand? Even that, I'm not sure is the best way to assess it. Do you follow me? So we, as a teacher, we teach you, we give you the words, we give you the framework, and we point you to a certain direction. But whether you get it or not, as for educators like us, we may never be able to precisely or accurately assess if you understand, but we can give you some questions to see. Okay, so we're trying to do that. Doesn't mean we're successful. Okay, so how to show work? The typical work to show for number 6, that's it. You're done. Okay, for number 5, how do you show work? For number 5, you just have to tell the reader, no solution. How to show work? How to show work? Do you follow me? If you are in any math class, including your math classes, you go to El Camino College, or math classes you're going to go in the future in your fabulous dream school, UC, CSU, Harvard, Stanford, anywhere you go. If this question is given to you, you just answer, that's your answer. That's your answer. You need no more explanation. Well, if you want to explain, you make sure you explain it properly. And your professor will be very happy. That's pretty straightforward. The important part is for your understanding. That's what I'm trying to do here. Do you follow me? So 2 kinds of sentences. And these are the if statement. We're trying to understand these. Okay. So can you promise me you're gonna try to think in these structures of sentences? Do you follow me? That's what I'm trying to do. All these yelling, you know, whatever I do here is try to get you to think in that direction. When you do this, you will see simplicity, I promise. Because all the work you do, you're working around these two sentences. One is a statement, one is if statement. That's all. And it's all about input, output. Sometimes you give an input, you ask for output. Sometimes you give an output, you ask for input. Okay, so this semester, I'm going to demonstrate to you how this is done. Okay, I keep myself on track. I keep myself on track. All right, so are we good? Can we move on to basic 5? Can we move on basic 5? Okay, so let's get on basic 5. Solve each inequalities. Okay, solution in inequality. Please. These questions seem to be very simple and the answers are typically very short, but yet in my past 20, I would say 25 years of teaching experience, okay, not including when I was a TA in graduate school, we saw persistent mistakes. We saw persistent mistakes. Easily, a student could lose 10, 20 points on these. For students who get it, easy points. For students don't get it, they keep making the same mistake. Same mistake. We see the same mistake over and over again, forever. It seems to be forever. Every semester we see these mistakes. And most interesting is that even after I have done the correction in class, we still see those mistakes. Okay, so my effort to explain these is for you to understand the mathematical meaning and how to express it properly. Okay, so even though they seem to be very simple, I want you guys to pay attention to it. Could you do that for me? So you will not lose those 5 points, 10 points along the way. Okay. All right, so let's begin. Interpretation. Absolute value of x less than 3. What is the interpretation? What is the interpretation? Still this function, right? With all of these properties, you know, absolute value is always greater than or equal to 0. All of these interpretations. And we talk about these interpretations, right? Do we have a similar scenario? I do copy and paste. I want to show you instead of less than 3, less than 3. Less than 3. Okay, less than 3. What is the interpretation? Do we have, of course, this is not the one, right? This is not the interpretation. I'm going to make some adjustments. Okay. Over here, it's a 3. I'm going to put broken line. Okay. Because it's a less than 3, I'm going to put circle. Over here, we're gonna put circle. Do you guys follow me? Circle, circle. Lesson 3. Lesson 3, okay? And the meaning is if the output is less than 3, where do you find output that are less than 3? We want to find all of the input, okay? We want to find all of the input. Want all of the input such that the output is less than 3. That's the interpretation. You see, it's still about the rule. It's still about the rule, and it's still about input output. We don't know we're looking for input, but we want the output to be less than 3. Do you follow me? So what are the input that will make the output less than 3? This is the output less than 3, isn't it? This is the output less than 3, isn't it? This output is less than 3, isn't it? Yes? So as a matter of fact, where do we find those output? Where do we find those input such that the output is less than 3? It's all of
Between
these here.
-3 and +3.
Between -3 and +3, that's right. Between -3 and +3. Does everybody follow me? And how do we express it? How do we express it mathematically, right? So you understand the meaning. That's important. That's an important beginning. Okay, that's an important beginning. Okay, but how do we express it? Okay, excuse me. A lot of our students can draw the pictures perfectly. But when they write the inequality, when we ask them to write the solution in equality, they make all kinds of mistakes. It's very frustrating. It's very frustrating for teachers, okay? And probably for you too, for students too, right? So the solution, I'm gonna draw the solution, okay? And I wanna make sure you guys understand what I'm saying. Okay, so our solution are gonna be just this line. Okay, and I'm going to clear all of these. Right? Are you with me? Everybody can draw this picture, right? What does this indicate? This indicates, okay, the meaning, this indicate that for this input here, the output is less than 3. Okay, this is the input. Okay, input, I'm going to use a different color. How about that? I'm going to use green. For this input, the output is less than 3. Yes? Another input, and the output is less than 3. You follow me? All the input is measured from the same place, which is from 0, but it's horizontal. All the output are vertical. Are you guys with me? So all of these numbers between -3 and +3 are solutions, and the same thing here. It's the same thing here, okay? And I hope you guys are paying attention to, because I really feel this is the most important part I have explained. Okay, and on this piece, okay, on this piece. I can make this just a little bit wider. Okay, so they're kind of comparable, right? From -3 to +3. I'm going to make just a little bit adjustment here so they look more comparable. -5, +5. Okay. Input output. Input output. So you can see these pictures, these two do agree, whether you use just the number line or you use this function perspective. Excuse me. So the solution is all the numbers between -3 and +3, right? We can say it by words. All the numbers. So let's write down the words. Let's write down the words. Every number between -3 and +3 is a solution. Okay, and here we're gonna put the words exclusive. Do you follow me? We can use the words. So this, sorry. This just implies, sorry. So this just implies that every number between -3 and +3, not including -3, +3, right? Not including, because we use circle to express it, right? Now, the mathematical form. The mathematical form is -3 less than x, and x is less than 3. That's the solution. This is the solution your math professors is dying to see. I don't know why we see all these other complications. Among these explanations, these wordings, the word "and" is a key word. The word "and" is the key word. Okay, the word "and" is the key word. Is that clear, everybody? All right. Okay, so now there are a lot of questions in basic 5, right? So I'm not going to stop here. I'm going to take the first question in basic 6. I'm going to take the first question in basic 6. We're going to do a comparative study. Okay, we're going to do a comparative study. So let's look at basic 6. Does everybody follow me? Okay, so let's look at basic 6. Basic 6, number 1. Okay, and this time it's absolute value of x greater than 3. Still about the rule, input, output, and we want the output to be what? We want the output to be what? We want the output to be what? Larger than 3, right? So from less than, it becomes larger. More than 3. More than 3, right? So the picture will change, right? And all these words will change. Do you follow me? All of these didn't change. I want you guys to draw that picture. Okay, so I'm going to make adjustment to these pictures. the other direction, right? To tell you the truth, I believe every one of you can draw these pictures perfectly. Okay, I believe every one of you can draw these pictures perfectly. Does everybody follow me? You got it, right? It's still about the rule. It's still about the input output, but this time we want the output to be larger than 3. Do you follow me? The good news is that every student I have encountered in the past, they all understand the picture and they draw the picture perfectly. So you're not alone, okay? Congratulations. But where do we see the problem? We see the problem in expressing the solution in inequality, which is much needed mathematically. So the solution would be any output, right? For these input, the output will be what? Will be greater than 3, right? That's output greater than 3. This output is greater than 3. And that output is larger than 3, right? And all these numbers are solutions. All of these are solutions. We have all these solutions. You follow me? The question is, how do we express it? How do we express it? No, not. I'm going to clear that. Okay, so now let me give you the correct mathematical form. Okay, for this piece, less than -3, we're going to write it as x less than -3, or x is larger than 3. Okay, and of course we can write down the words. Okay, let's write down the words. Okay, every number that is less than -3 or greater than 3 is a solution. Every number that is less than 3, less than -3 or greater than 3 is a solution. Does everybody follow me? It's pretty straightforward, isn't it? However, when we grade our students' paper in the past, okay, I haven't graded your paper on this topic, okay? We see all kind of mistakes, One of the typical mistakes, a popular mistake, is this student will write -3 larger than x larger than 3. Did you write it down? Did you guys write it down? This is probably one of the most popular mistake I have seen in my entire career. Okay. What does this mean? Mathematical sentences are usually very strict, and the use of symbol is very strict in terms of its meaning. There's no ambiguity. For example, when we were talking about the solution here, what is the key word we use here? We use and. We use and, right? By convention, what does that mean? When you put numbers in this kind of relationship, it only means and. If it only means and, it will never mean otherwise, whether you put it this way or that way, right? For example, I can write it this way. I can write it this way, 3 larger than x, larger than -3, right? I can totally write it that way. So when you have the signs like this lining up, it always means and. It will never mean anything else. Do you follow me? And this mistake, this popular mistake, you may think that's a condensed form of writing this or, but you're gonna lose all 3 points of your work. Because the meaning is this: every number that is larger than 3 and smaller than -3, okay, exclusive is a solution. That's that's when your math professor read this, that's the meaning. I don't know whatever other meaning you attach to it. Okay, whatever other meaning you may attach to it. Okay, all the students who make this mistake, they will tell us, they write this way, they mean that. But that's not what your math professor is thinking. He or she is thinking when you write it this way, that's what you meant. Do you follow me? Can you tell the difference? Can you tell the difference?
Yeah, so in this one, the person would be saying that they would be including the numbers that are in between -3 and 3, right? Like 0 and
Does such number exist? Can you give me a number that's larger than 3 and smaller than -3 at the same time? The key words is and.
1.
What?
1.
1 is larger than 3?
Yeah, I was just saying that they would be including those numbers, and that would be incorrect.
It doesn't. It's a junk. It's a piece of trash. You follow me? That's what I'm telling you. No matter what you really meant, this is your professor's interpretation. This is your professor's interpretation. Anywhere you go, this is a piece of trash. Because such a number does not exist. Do you guys follow me? Does everybody follow me? I've been trying to correct this mistake for more than 25 years. you will see this mistake on your quizzes. And I hope you identify and you will not make that mistake. Okay, I will also be giving you written quizzes to see if you are going to make that mistake. I hope I will not see it. I certainly hope I will not see it. If I do see it, well, so be it. Okay, so you must understand this grammar of mathematics. Do you guys follow me? That's what I'm trying to get it to you. Only two kind of sentences. Every symbol has its own unambiguous meaning. If you want to inject new meaning to a symbol, you better verify that with the meaning in mathematics yourself. You follow me? If you create a new meaning to it and you say, oh, this is what I meant, and your professor will not read it the same way, then you need to reflect and you need to change. You follow me? Because this mention of mathematics is built on very carefully worded language and logically built. If anything is, any minor thing is changed, right? In the past, we talk about principle number 4. If you remove the condition C is not equal to 0, you're gonna get a 1 equals to 2, right? We saw that. So every little thing, you really have to make sure you understand, and I'm teaching to understanding. Okay? All right, I hope we can put this behind us, shall we? Okay. So in terms of inequalities, in terms of these basic 4, 5, 6, I think I have covered them. I have covered them, okay? We still have some time for the rest of the class. We're gonna do some exercise. We're gonna do some exercise. Okay, we're gonna do some exercise. So I want you guys to pick up questions from number 5 and number 6. You pick up 2 questions or 3 questions from basic 5, basic 6, and you're gonna work them and we're gonna discuss. Okay, we're gonna discuss. And meanwhile, I'm gonna give you a summary of what we just covered. Okay, so pick 3 questions, pick 2 or 3 questions in 5 and pick 2 or 3 questions in 6. Okay, and then we're gonna converge. And meanwhile, I'm gonna make you a summary. How's it going?
Still working on them.
Good. If you have any questions, bring your questions to me, please.
I'll finish them first and then I'll ask the questions.
Sure, yeah. Everybody, please don't hesitate to ask questions, okay? I really want to help you guys get over this kind of questions. So you're not going to, so you won't be losing those points. You will not be losing those points, okay? Easily losing. I've seen students losing 5 points, 10 points here, you know, on the graph, on the narrative, right? Easy. Reflect on the meaning, okay? Reflect on the meaning is the key, okay? It's a key. And you sometimes see some negative numbers, you see zeros, and you see all of that. All the tools you need is here. It's right in front of you. Okay, you just have to make sure you understand what it means. And to give you a tip about, some of you might have difficulty understanding these symbols, right? This symbol, are you guys following me? This symbol, sometimes you see this symbol being like this way, or sometimes you see the symbol this way. Okay, how do you tell the difference? Well, on the pointed sides, it's always a smaller number. On the other side, it's always larger. Okay, and the same thing, this side is larger and the other side is always smaller. Does that make sense? It's consistent. It's consistent. If that would help. Okay, the quantities that the meanings is consistent. So you just which way you write it. But the opening side is always opens to the larger number, and the pointed side always opens to the smaller number. Make sense? And in this case, an and is implied. Okay, and is implied. Okay, and is implied. It's a shorthand notation. Okay. All right, so we have 8 minutes left. I do want to take some of your questions, and I'm sure you do have questions.
So I did number 10 on basics 5, which is absolute value is less than or equal to 3.2. So for that, I just got x less than or equal to 3.2.
You say number 10?
Yeah,
So what you get?
x equals is less than or equal to 3.2.
It should be between negative 3.2 to positive 3.2. Okay, so let me get to your question.
Yeah, that's what I wasn't sure about. I wasn't sure if I had to. Oh, you know, now it makes sense because it can be negative.
Of course. The only thing the picture will change will become the 3.2, 3.2, 3.2, isn't it?
Yeah, okay, I see where.
Okay, so you're talking about number 5? Oh, basic 5, number 10, right?
Mm-hmm.
Okay, could you allow me to show you what has changed, what has not changed? Does everybody follow me? Is this a question? Is this a question? Right? Now, less than equals to 3.2. So this picture, oh, hold on. What did I do here? Okay. So this entire picture, right? As it applied to this situation. Okay, I'm going to put it as think out aloud. Okay. Less than or equal to 3.2, meaning it include less than 3.2 or equal to 3.2. And this case is not referred to. So all these points will change from 3.2 to 3.2. And of course, I need to make adjustment on these pictures. It will be 3.2. Do you guys follow me? And these will be 3.2, 3.2. That's all you need to change. So what will be the solution? So your solution would be as far as showing work, if your professor gave you a question like this, and this is all you have to do. That's it, you're done. You get all the credits. Then you say, how about these pictures? Well, these pictures you don't need to show your professor, right? And most of you know these pictures. Do you guys follow me? Do you guys follow me? Does everybody follow me? Next question. You don't excuse me. You don't need to show anything else. You don't really need to show anything else. Question?
Yeah, I did basic 6, number 11.
Basic 6, number 11.
Mm-hmm. And that is the absolute value of x is greater than or equal to 0.
Okay. Basics 6, number 11. That's the absolute value of x greater than or equal to 0.
Yes.
So what is the solution?
I put that all numbers, including 0, are solutions.
Your answer is right, but you can make it simpler.
Okay.
All real numbers are solutions. You don't need to mention 0 because all real numbers include 0. You follow me? This is basically confirming this statement. Do you follow me? Do you guys see that? You're really using these statements. And what it means is that you have input, that's the output, right? And they say, okay, we want the output, to be greater than or equal to 0. Give me all the input. That's the question. You follow me? So what are the input that will make that happen? Well, that's every possible input will make that happen, right? And therefore, the solution is all real numbers. So when you do this kind of question, like when you do number 11, that's all you need to tell your professor. You don't need to do more. You don't need to write more, but in your mind, you understand these concepts. You know, you need to understand when you write down mathematics, there's a lot of words are not necessary to put down there. But if you do put down there, you want to make sure it's correct. Every statement counts because when I grade your work, I will look at every word, every symbol you put in there. And I will interpret it, and your other professor will do the same. I will interpret it according to the grammar of mathematics. We don't invent our own words or grammars and stuff like that because I'm not qualified. I wasn't born before these grammars were created. You guys follow me? So do you. All right. Any other questions? We have 1 more minute left. I will be giving you a quiz today. I'm going to give you a written quiz. Okay. And I'll be grading your the quiz last week, and I will give you a written quiz today. I want you to get to it as soon as possible. Okay. I pointed out some mistakes, and I will give you another quiz that's multiple choice this week. So you'll be having 2 quizzes about absolute value this week. Do you hate me? Not yet. Okay, so now do you understand your focus? Do you understand your focus? Right? The rule, input, output. We work with different rules. That's all. That's all. Okay, we come to the end of the class, but I'm looking forward to seeing you tomorrow. And I will have the quiz ready for you to work on. Okay, and once again, written quiz, you get opportunity to make to earn extra credit. All right, but once again, please, please, please don't hesitate to bring your questions to me. Okay, I'll be delighted to see you, of course, and I'm also delighted to see your questions. All right, I'll be heading to my office hours, and I'll see you tomorrow, if not sooner. The homework has been assigned. Very good job, you guys. Okay, very good participation. You know, I know you guys will get this. You will get this, so you will not lose those points. Okay, and I'm sure you can do it. You can do it. All right. So guys, see you tomorrow, if not sooner. Let me see. There's chat question. All right. I'm sorry, I overlooked the chat, and plus minus D. I'm sorry, Kyle, I missed your question. I missed the context, but if you want to clarify, please come to my office, okay?
Oh no, it's just that you're telling us to give you like ABC answers, and that was like one of the answers. But that was just like a random answer, just to put out there. That's not what I thought.
Oh, okay, okay, good.
Yeah. Okay.
But you know that's wrong. That's not correct, right?
Yeah, right.
Okay, good. Okay.
Okay.
Thank you. I
Thank you.
apologize for I didn't get it sooner. Good job. Very good job. Okay. I will see you guys tomorrow, if not sooner.
Great. Have a great day.
You too,
Thank you.
of course.